Good morning time, good afternoon time, whatever the case may be in your part of the world. Today we are going to be discussing why running a higher voltage system is theoretically more efficient. All right. And to do that, I will simply be using the formula for power to prove my point. Now, I've always said, even back in my Frank days, that when I get to running the system that I prefer to run, that would be 120 volt system. Now I know many of you are gonna say, "Wow, 120 volts," but it's not as bad as it sounds, and not as serious as it sounds. In fact, I'm going to show you why running a higher voltage system is a good thing. Now, the formula for power is amps times volts equals watts. Okay? So, let me show you some math here. And hopefully you'll be able to see that on here. Let's see. Anyway, we're going to try our best. All right, now let's do some hypothetical now. Now, I just told you amps times volts equals watts. So let's say you're running a 72 volt system, okay? And let's say you're running a 72 volt system with a 100 amp controller, and you're actually using 100 amps. You're actually drawing 100 amps from your battery. So our formula for power, 72 volts times 100 amps, and these numbers are going to be nice and easy because they're even. That gives us, 7,200 watts. Okay, 72 volts times 100 amps, that equals 7,200 watts or 7.2K. All right, you with me? All right. 7,200 watts is the amount of power that we're producing and we're generating at the motor. 7,200 watts. Now, let's say, all right, first of all, let's go back over that formula for power. Amps times volts equals watts. So if you would want to determine how many amps you're running, you would shift this formula around a little bit. You would take the watts and divide it by the voltage, and that in turn would give you how many amps you're drawing, right? So we just did it. We can do this in reverse now. 7,200 watts divided by 72 volts, that's going to give us our amps back again. 100 amps, all right? All right, now let's go back to our 7,200 watts of power. Let's say that we increased our 72 volt system. And stand up now with my legs cramping. We increased our voltage to 96 volts, all right, with the same amount of power output. So let's see how many amps we're drawing with a higher voltage system. 7,200 watts divided by 96 volts. Now we're getting that same amount of power with 75 amps. Sorry, not trying to confuse you by saying the wrong thing. 75 amps. At first, on 72 volts, it was taking us 100 amps to make 7,200 watts. Now it's only taking us 75 amps because our voltage went up. All right. Now let's take our voltage up some more. Let's go back to our power output, 7,200 watts. Let's say now we increase our battery system to 120 volts. So 7,200 watts divided by 120 volts, now it's only causing us to use 60 amps to make that same amount of power. You see, as you increase your voltage, the amount of current that's required to produce that same amount of power goes down. Okay? Now, what do you think, what type of benefits are you getting from your current going down? For one, where you were initially putting 100 amps through that motor to make that 7,200 watts, now you're only putting 60 amps through there, which is almost half. That alone is cutting our amps in half, and that will make the amount of heat that our motor is producing, because heat is a side effect you get from producing power. All right, anytime you're producing power, you're going to create heat. Now, we went from 100 amps down to 60 amps. So that motor will run a lot cooler at 60 amps as opposed to 100 amps. No doubt about that. So that motor will be running cooler. Not only that, our battery itself will, each individual cell will actually perform more efficiently and not produce as much heat. Let's say you have a 10p battery. That's the cells in parallel. And let's say that 10p battery, each cell can produce 20 amps. All right. So if you have a 10p battery, that battery is capable of producing 200 amps. Now, initially, that battery was producing 100 amps to make that amount of power, and that was creating some heat. All right. But we cut that almost in half. We went from 100 amps to 60 amps. So now each individual cell is producing less amps than it had to originally. Now let's see. Let's see how many amps each cell would have to produce to make that 100 amps. If that's a 10p battery, and those cells can make 20 amps a piece. But let's just see. If it's a 10p battery, matter of fact, I don't even have to do it on the calculator, but I'll do it anyway. So 100 amps divided by 10 cells, that means each cell had to produce 10 amps, okay? Which is half the amount of power that those cells are capable of producing. We said each of those cells could produce 20 amps. But, you know, in our first setup with the 72 volts, that battery was producing 100 amps to make that 7,200 watts. All right. Then we went down to 60 amps. Okay. So as opposed to each cell having to create 10 amps per cell, let's do the 60 amps. 10 cells. Doing that wrong. 60 amps divided by 10. Now each cell only has to produce 6 amps. You see? Because initially each cell had to produce 10 amps to make the 100 amps. Now each cell only has to produce 6 amps. And 6, as in comparison to 10, is not exactly half, but it's almost half. So those cells that were outputting 10 amps now only have to produce 6. So those cells are going to run a lot cooler, making that same amount of power. Now, that battery will be larger as far as how many cells are in series, because you need maybe like a 31S battery or 32S battery to make 120. And it's a 20S to make 72. So it's a lot more cells in series, but it's going to be the same amount of cells in parallel, whether it's 72 volts or 120 volts. The parallel is going to be the same. So, yeah. What the bottom line to that is running higher voltage is going to be a lot easier on your motor and a lot easier on your battery. And I showed you the math right here. I'm sure there's going to be somebody that disputes that, but you can't dispute the math. The math is what it is. And like I used to tell people all the time, electronics is nothing but math at the end of the day. There's a formula for everything. And we basically were just going over the formula for power. You know what I mean? I can show you again with some larger wattage. All right, let's just say for kicks. Let's say we were creating 20,000 watts. 20,000 watts, okay? And let's see how many amps a 72 volt battery has to create to make 20,000 watts. So that would be 20,000 divided by 72. That's going to give us our amps. Okay, to make 20,000 watts with a 72 volt, we need 277 amps. All right, that's how much our battery has to output to make 20,000 watts with a 72 volt. Now, let's say that same 20,000 watts, 20,000 watts divided by, let's say, 120 volt battery. That's how many amps a 120 volt battery has to produce. So 20,000 divided by 120 is 166 amps. That's a big difference. Now, being an old man, I forgot what the first one, where was it? 211? Something like that? I believe so. But now it's only taking us 166 amps to produce that same 20,000 watts. And just because I'm an old man, let me go back to the first one. 20,000 watts divided by 72. I think it was, no, it wasn't 211. It was 277. 277 amps it takes for a 72 volt to create 20,000 watts. And it only takes 166 amps for 120 volt. That's almost 100 amps. Almost 100 amps. And that's a big difference. So, almost any battery can produce 166 amps. But for a battery to produce 277 amps, that's a lot of amps. Not only that, your range will also increase because you're using a higher voltage system. It can be the same amp hour, 120 volt. Let's say that 120 volt battery was 40 amp hour and the 72 volt battery was 40 amp hour. Now just imagine that 72 volt battery to make 20,000 watts needed 266 amps. How long do you think that 40 amp hour 72 volt would last? Taking 266 amps when that 120 volt 40 amp hour only needs 166 amps to produce the same amount of watts. That means you would get longer range out of that 120 volt battery. Your system will end up being more efficient on higher voltage. That was my point. That was my theory that I always used to say back in the day before I had this bike, before I had the Blue Bomber, before I had any of those other bikes I have now, back when I had Frank. I always said I wanted to run a high voltage system so I could use less amps. Using less amps to create the same amount of power puts less stress on your batteries, puts less stress on your motor. Not only that, the heat that you produce by running less amps on your motor and your battery is going to save everything in the end. Higher voltage puts less demands on your system, period. It will save your motor in the end, and it will save your batteries from depleting as fast in your cycles, because the demand on your batteries isn't as great, because the batteries now only have to produce almost half the amount of current they were producing originally. So that is my theory. I'm gonna stick with it. Ain't no doubt about it. Wholeheartedly, I have 100% faith in that theory will work. No doubt about it. It's simple math all day long. All right, y'all. So that is my little lesson for today. The title of this video will be something like higher voltage battery systems are more efficient. And, you know, I have some other little stuff in the other part as to why that is true. But I just showed you in that formula, that power formula. It's simple math. That's all it is. All right, y'all, take it easy. Take care. We going to a high voltage system. Simple as that. Y'all can do what y'all want to do, but I'm going to use a little bit of science and technology to do what I'm doing. Deuces. We out. It's a Crooked Finger production, y'all. And there it is. Crooked ass finger. We out of here.